Hello, my name is Thomas Trauch. Today we are going to talk about Proposition 2 of Gottfried Wilhelm Leibniz's work on the quadrature of the circle, parabola and hyperbola. In Proposition 2, Leibniz is dealing with a series of quantities, and he's dividing the series of quantities in two different types, namely a series of natural order and series of disturbed order. And he says that an order or a series, or the order of a series is natural if the series progresses only from the smaller to the larger, or from the larger to the smaller, but never at the same time from the smaller to the larger and from the larger to the smaller in the same series. And if the latter one is the case, the series is called disturbed, because in the same series you find sections where you have the series quantities ascending from the smaller to the larger, and some other section of the series it descends again, maybe from the larger to the smaller, or the other way around. And this is how he divides the two types of series. So let's look at the series of natural order. We prepared a little example of three elements, a series containing three elements, and we have three quantities here, A, B, and C, and the series is made up of a succession of elements, the first one being A, the second one being A plus B, and the third one being A plus B plus C. And when you create the differences between each of these elements, for instance A, or the first element and the second element, you have A and A plus B, the difference is going to be B. And for the second step, or the difference between the second element and the third element, the difference is gonna be C. And now when you build the sum of these differences for the entire series, in this case the sum of the differences of this natural order is going to be B plus C. Alright, so if we look now at the disturbed order, remember this is the case where in the same series you have parts of the series descending and another part of the series is ascending again progressively in quantity from element to element. And the nature of this series is a little different from the one in the natural order series. So in the first element, this time we have the quantities A plus B, in the second one quantity A, and in the third one A plus B plus C. And so the difference between the first and the second element is going to be B, while the same difference between the second element and the third element is going to be B plus C. And when you again build the sum of these differences of the whole series, then you get 2B plus C. Yeah, B plus C is equal to 2B plus C. And from this, Leibniz concludes that no matter how you twist or turn it, the sum of the differences of a series of natural order is always smaller than the sum of differences of a series of disturbed order. Because as you see, for the natural order we have as a sum, in this case B plus C, and the sum of differences for the disturbed order is 2B plus C. And you can actually test this with any amount of elements and have them being natural in one way or in the other, and another series being disturbed, meaning they ascend and descend in the same series in different sections. You will find that this principle will always be valid. The sum of differences between the elements successively will be always smaller for the natural order than it is for the disturbed order, if both series, natural or disturbed, contain the same elements. And that is a relationship which he later uses in another proposition to do a proof on the equality of two certain areas which have to do with the quadrature of the circle. And this is what we're going to take on in a later proposition. But before that, we will go through a number of propositions, namely until proposition 5, where we deal with these kind of principles within a series of quantities. Okay, this is all for proposition 2 so far, and I hope you stay tuned for the next one, proposition 3, coming up. Thank you very much, and bye-bye.